In this video, we're going to be going over part 3 of a Unit 1 Kinematics MCQ practice for AP Physics 1. So we have question 1, a particle moves such that its position is given by x is equal to t cubed minus 6t squared plus 9t. At what time is the velocity equal to 0? So this concept is actually an AP Physics C concept, which requires to take the derivative of the position, because velocity is equal to this derivative. Now, if you do that, you're going to have v is equal to 3t squared minus 12t plus 9 divided by 3. So then if we divide both sides by 3, then we get the simplified form where t squared minus 4t plus 3 is equal to 0. We factor that, we get t minus 1 times t minus 3 is equal to 0, and you get t is equal to 1 and 3. So your answers would be A and C. That's because the velocity is going to be 0 at your turning points where the derivative is equal to 0. Now, if you have two objects thrown from the same height, one is thrown upward while the other one downward with the same speed, which of them hits the ground first? Well, if you have one object at one height, then you just drop it straight down, so it gets there to the bottom faster. But if you have from the bottom, you throw it up, then it has to go back down as well. So it has to go back up, and it has to go both up and then down. So it's going to take longer time. So the downward object that just goes straight down first is going to be the quicker option that takes less time. An object has 0 velocity at some instant. What must be true? Well, if you have 0 velocity, A is not going to be right, because just because your acceleration is 0, it doesn't mean that your velocity itself is equal to 0, because A is just a change in velocity over time. And in a case scenario where you had change in velocity is equal to 0, that would make your acceleration is equal to 0. But getting change in velocity, you could, for example, have 3 minus 3 is equal to 0. But that would mean that you started with 3 and you ended with 3 as well. But those are not equal to 0. Just the difference between them is equal to 0. So that's false. That is something that implies something that it's not. So you can't just assume. It is at its maximum height. Well, if you think about if it's at its maximum height, this is not always going to be true, because there are other instances where you could have 0 velocity. Like, you could just start out with 0 velocity. It is changing direction. Well, this is only if it's a turning point, but we can't know that for sure. So the answer is going to be none of the above. A velocity versus time graph is a straight line with a positive slope. Which of the following is true? Well, delta v over t is equal to acceleration. So this A is going to be constant, because the average rate of change is going to be constant. Constant slope means a constant A. Now, your answer is going to be B. Now, if you have two cars moving in opposite directions at 10 meters per second each, your relative velocity is going to be what? Well, your v relative is equal to v1 plus v2. So you have 10 plus 10 is equal to 20. So if you have opposite directions, you would have added a projectile is launched horizontally. What is true? Horizontally, ax is equal to 0 and vx is equal to a constant value. Vertically, ay is equal to d and vy is going to be changing. A projectile reaches its maximum height. At that instant, our answer is going to be that vx is not equal to 0, since vx has to continue the movement this way. These are not true. A ball is thrown at an angle theta. The range maximum is going to be at what? Well, this is our formula for range. If we have a maximum range, sine 2 of theta must be equal to 1. So if we have 2 of theta, this is going to have to equal to 90 degrees. Therefore, if we divide both sides by 2, we get theta is equal to 45 degrees. If the launch speed doubles, what happens to the range? Well, if our range is equal to v squared sine to theta over g, r is proportional to v squared, we're going to have 2v squared is equal to 4v squared, because we just substitute and double the speed. And if you sub and double the speed, that is going to give you 4v squared. And that's b. 4 times an object travels 10 meters to the east, and then 10 meters to the west. So the distance is equal to 10 plus 10, 20. Displacement is our initial, and this is our final. So we actually traveled 10 minus 10, which is 0. Displacement takes into account the direction. Because this direction is positive 10, this is negative 10. So you end up back where you started, where we're going to have B. A plane flies north at 200 meters per second and with a wind at 150 meters per second to the east. The ground speed is going to be what? We go north 200, then we go to the east 150, so magnitude C. A swimmer aims directly across the water. They land downstream. Why? Well, if we have a swimmer's velocity, that's going to be across, and the river is going to have a velocity downstream. So this is the water. That means that the resultant is going to be a diagonal down the stream. The reason why they end up down the stream is going to be because the water pushes them. The river's velocity is going to add to the swimmer's motion, which graph shows 0 acceleration. Well, acceleration is slope of v of t. That's going to be c. A projectile launches upward and then returns to the launch height. Its final velocity compared to the initial is going to be what? It's going to be opposite, because the final velocity is going to be equal to the initial velocity. However, the only difference is they're going to have opposite direction. Since this one's going up, this one's going down. At the highest point of a projectile, what's true? Vy is equal to 0, because that's the transition point of the direction. Let's say that we have a ball dropped and a ball thrown horizontally are going to hit the ground. How are we going to figure out what these two have? Well, we know vertical motion determines time. We know both have the same h initial. They have the same acceleration in the vertical direction, and they have the same vertical velocity initially. So they're going to have the same time, because Vx doesn't affect fall time t. relative velocity is going to be what? It's VA minus VB. It's the difference between velocities. A projectile launched at an angle theta. The time of flight depends on what? We have this equation. We have vertical velocity, we have height, and we have gravity. So we have Vy, which is a part of our equation. Only vertical motion determines the time in this of these options. An object slows down while moving, positive. That means acceleration has to be opposing our velocity. Therefore, acceleration is negative because we're slowing down. Two projectiles launched at 20 degrees and 70 degrees, which has the same range. Well, r is equal to this formula, sine 2 theta. 20 degrees gives us sine 40 degrees. Sine of 2 times 70 degrees will give you sine of 140 degrees. And these are actually equal to each other in terms of height. So both. This is because complementary angles give the same range. An object's velocity changes, but speed is always constant. If the speed's always constant, you have the same magnitude. If your velocity changes, that means that your direction changes. B. Horizontal and vertical motion are independent of each other because why? Well, we know that FG is always going to be vertical. There's no horizontal force, right? So the reason is because gravity only acts vertically. And because motion in perpendicular direction is independent when the force only acts in one direction. So directly on the vertical axis, 90 degrees, 270, or only on the horizontal axis, 0 degrees, 180. A projectile launched from a cliff travels farther than from the ground, because why? Well, if you have more time in the air, that means you have a greater horizontal distance. So that's going to mean you have a longer time. If you have an increased time of flight, that's going to mean an increased range. A ball is thrown up. At halfway up, what's the speed? Well, we have time symmetry. If you're going to be halfway in height, that means that half of your height is here. That's because your V is not linear. V is squared. So for 24, what we have is that none of these are guaranteed to be true. Now, a car accelerates uniformly. What graph is going to be linear? If it accelerates uniformly, our VT slope is equal to acceleration, and a constant acceleration is equal to straight line.